Or here we look at the last part of section 8.2, where we're going to try to figure out how big of a sample we need so that our margin of error is within a certain value, a certain range of values that we're interested in. All right. So again, we're going to determine the sample size required so that our confidence interval is within a certain specific margin of error. All right, so in planning a study, we would like our margin of error to be a certain amount. So like, for example, when we have election polls, and we try to say, what proportion of the people of the electorate are going to vote for a particular candidate, we have at the end, they say, it's 50% of the possible voters in our poll are going to vote for the particular candidate. And then we will say with a margin of error of plus or minus 3%. And so how do we establish a certain margin of error? So we would like certain margin of errors to start with. And so what we have to know is how big of a sample we need so that we get a margin of error that's acceptable to us. And so if we look at what the margin of error is, remember the margin of error is just the critical value or Z star value times the standard error of the statistic. So the margin of error is made up of those things. Okay, because the margin of error involves a sample proportion p hat, which we haven't actually done yet, like we haven't taken a poll, so we don't know what the result of the poll is going to be. We don't know what our p hat is going to be. So this causes a problem, right? So we could solve this equation for n and find how big of a sample do we need if we knew what our p hat was. And so we have two ways to deal with not knowing p hat while we're trying to choose our sample size. And so the first option is we're going to guess at a p hat based on past experience or a pilot study. If we're, say, for example, if we're looking at the proportion of seniors who are going to attend prom, right? How many students do we need to poll in order to get a margin of error that's acceptable to us? And because the larger the sample size, the smaller the sampling distribution. So the normal curve will have a smaller standard deviation. And as a result, the margin of error will be smaller. So what we want to do is, look at, the last 5 years, 42% of all seniors went to prom. So we can use a p hat of 42%. Some sort of past experience or some smaller study, like, okay, well, let's do a sample of 20 and see what the p hat from our sample of 20 is, and we'll use that as our p hat. So a pilot study or some past experience that we know of. And then, that would be great. Or the worst case scenario, best, if we have nothing else to do, we don't have any past experience, we don't have a pilot study or the ability to do one of those, then we'll just use a p hat of 0.5. And so my question to you is why? Why would we use just 0.5? If we don't have anything else, worst case, why would we use 0.5? And the result is, if you think about it, when is p hat times 1 minus p hat the largest? And so that's the largest when we have a 0.5. So if we use, say, 0.3 and 0.7, right? The p hat of 0.3, 1 minus p hat is 0.7. That's actually going to be smaller, right? So we want the largest margin of error. We don't want a large margin of error, but we want to know, like, okay, a p hat of 0.5 will give us the largest margin of error. So if we set that up first, then we'll never have a margin of error larger. If anything, we'll have a smaller margin of error, but we'll never have a larger margin of error because our p hat and 1 minus p hat, the product will always be smaller than it is when p hat is 0.5. So that means our margin of error will never be larger than what we wanted if we just assume a p hat of 0.5. Okay, so this is the formula that we're going to use to determine our n that we need for a particular margin of error. So determine the sample size n that will yield a confidence interval C for a population proportion P with the maximum margin of error that we're allowed to accept. So for example, if we want our poll to be plus or minus 3%, so let's say we want a margin of error to be 3%, we'll plug everything else in and we'll solve for n, and we'll do that in an example right now, okay? All right, a company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that is she's going to, because the bigger the sample, the more expensive it will be to run the poll. So she wants an idea of how large of a sample she's going to have to pay for. So one critical question is the degree of satisfaction with customer service. And so we use, in that case, it's going to be measured on a 5-point scale. So the president wants to estimate the proportion, P, of customers, that's the population proportion, of customers who are satisfied, that is, either satisfied or very satisfied, the two highest level on the 4-point scale. So that's one question that we're going to concentrate on. And she decides she wants the estimate to be within 3%. So that means our margin of error will be 0.03. And then she also has decided that she wants a 95% confidence level. All right, so how big of a sample is needed in this case? All right, so we want our margin of error to be within 3%. So if it's smaller than 3%, that's fine. But what can't be bigger, cannot be larger than 3%. All right, so the critical Z value for 95%, you can use your inverse norm in your calculator or use the Z table and Z-score table. And there's one way or another, your critical Z value or Z star is 1.96. What else do we need? We really don't have any idea. We don't have any past experience. They didn't give us any information. They didn't run a pilot study. So we will use a p hat of 0.5. So worst case, if we don't have anything else, we just use p hat of 0.5. All right, and then we want our margin of error to be no more than 3%. So we plug all those things in to the formula on the last slide. Margin of error must be less than 0.03. And so plugging everything in gives us this. All right, so the margin of error, which is the critical Z star value times the standard error of the statistic. The only thing missing is n. So instead of leaving it as a fraction underneath one radical, we remember from algebra 2 that we can take and split this fraction under the radical into a fraction of radicals, right? So this will help us algebraically be able to solve the square root of n. So we want to get the square root of n by itself. So we would simply multiply both sides by the square root of n and divide both sides by 0.03. That gives us this. So we really want ultimately n by itself. And so we have a square root inequalities. So in algebra 2, this was actually a pretty complicated formula, but in our case, we know n is greater than 0. It's positive, right? So we don't have to really worry too much about verifying that our n is not going to be, a negative and all kinds of other things. So in this case, we would simply square both sides of the equation. And so that gives us this. And so, we in algebra 2, we didn't like to do that. We didn't like square both sides of the equation when we have square roots. But in this case, we don't have to worry. N is always going to be positive. So now we just solve this. We just take all that and plug it into a calculator on the left-hand side. And we get 1067.111 is less than or equal to n. And so what would our n value be? So in other words, if we want it, again, what's the whole point of this is we want our sample size to be such that our margin of error is never larger than 0.03 or 3%. So you might be tempted to just say, oh, we'll use 1067. However, 1067, right, will be a little bit smaller n, and so a smaller n would make the standard deviation of the sampling distribution a little bit wider, and so as a result, our margin of error might be slightly more than 3%. So what we want to do is go up. So we're not rounding here. We're simply taking that value and going up to the next biggest integer. So instead of rounding down to 1067, we will go up to 1068, and that absolutely guarantees that our margin of error will be smaller than 3%, rather than possibly being slightly bigger. All right, so we don't really need to look at anything in this slide. So, basically what we did here was look at in this video is we looked at determining sample size required to achieve a confidence interval of a certain level with a certain margin of error. All right, your homework is listed here, and that is due next class.